Thank you for the introduction, and good morning, everyone. So cars have complex forms, often called moving sculptures. They must look beautiful from every viewpoint while being harmonious as a single and coherent shape. So therefore, in the early stages of car design, designers must produce view-consistent renderings from different viewpoints to express and communicate their ideas. These renderings that serve as the foundation not only for design reviews, but also for building scale models, clay models, and even advanced 3D CAD modeling all throughout the design process. However, when designers create sketches and generate renderings from different viewpoints, the output often lack view consistency, making it difficult to represent the same 3D shape. And this often makes designers to generate images over and over until they get a usable set, which is pretty much like pulling a slot machine. So to overcome this challenge, car designers nowadays resort to 3D modeling. They capture different views of the model and use them as inputs to generate view-consistent renderings from different viewpoints. However, investing time and effort into 3D modeling early in the design process, only to produce 2D images, can be considered bad practice, as it can cause bottlenecks and limit design exploration. Instead, designers need better backbones that are quick to create, expressive in capturing the complex forms of cars, and iterative enough to evolve with new ideas as they emerge. For this reason, we propose a workflow that leverages 3D sketching rather than committing to 3D CAD modeling too early in the design process. 3D sketching is very similar to how designers actually sketch on paper with a pen, which makes it quick and iterative, but still expressive enough to capture complex forms of cars at the same time. And using 3D sketches as a backbones, designers can capture an image of them from a chosen viewpoint and easily obtain realistic renderings from as many viewpoints as designers need. Furthermore, in our workflow, designers can seamlessly transition between 3D and 2D, letting designers progressively develop their designs. So let me show you in detail how it works. First, 3D sketching. Car designers often build upon existing cars rather than beginning from zero. So similarly, in our system, designers can use 3D car models as underlays. And referring to the underlay, designers can express new exterior concepts using 4 classic 3D sketching methods that we finely tuned for car design. When sketching on a plane, designers can set up a sketch plane by moving one of the grid planes, observing cross-section of the car, and enter the orthographic view for precise drawing and draw curves on it, which result in 3D planar curves like this. When drawing on a surface, designers can select profile curves and extrude them in the desired direction to create sketch surfaces, and navigate freely and draw curves onto the sketch surface, resulting in 3D spatial curves like this. When drawing on a mesh, the system automatically reconstructs a watertight 3D mesh from the sketch curves within 30 seconds. So once the reconstruction is complete, designers can view it from different angles and use the mesh as a canvas and directly draw onto it to express details, such as headlights on the front, or air intakes on the hood, and more. Lastly, when sketching in the air, designers can either draw a pair of symmetric curves from one viewpoint, or sketch the one curve, change the viewpoint, and draw the same curve from different viewpoints. Now that we've explored 3D sketching, let's move into 2D. When a 3D sketch is captured from a viewpoint, it contains many overlapping curves, and they make it difficult to clearly recognize the shape. So to address this, our system generates a mesh from sketch curves within a few seconds, using it to determine which curves must be shown and which curves should be hidden. So this mesh is a bit different from what we use for 3D sketching. It's just a rough pseudo mesh that we can reconstruct quickly while still accurately capturing the overall silhouette of the car. So when designers capture the 3D sketch, the system converts into clean line drawing and opens it to Photoshop, which is the most familiar tool to car designers. They can then add further design intents such as silhouette, details, and shading, which is more effective to do in 2D. Lastly, 2D generation. So when designers return to our system, their drawings are automatically loaded and can be used as input to generate 2D renderings like this. And designers can collect inspiring images and place them anywhere on the screen for later use. Furthermore, designers can perform all of this, seamlessly transitioning between as many viewpoints as they need. So to evaluate the benefits of our proposed system for car exterior design practice, we invited 6 professional car designers to participate in a workshop. They were asked to create new design concepts across all 12 standard car body types, ranging from super mini to pickup. And they used our system, produce rendering sets for front three-quarter view, side view, and rear three-quarter view, which are the principal views in car design. The workshop consists of 3 sessions. Designers first spend 1 hour learning the system, then 3 hours designing 2 cars for each, and finally 1 hour in a debriefing session where they reply to our surveys and then reviewed time-lapse videos of their work with the authors. So every designer quickly learned how to do 3D sketching in our system, and they applied all 4 3D sketching methods during the task and successfully produced refined 3D sketches of new exterior concepts for all 12 car body types. And using the 3D sketches as backbones, they produced high-quality rendering sets in an average of 1 hour and 20 minutes. So designers mentioned that achieving similar results with traditional 2D workflows would take 4 to 5 times longer that contain only 2D drawing and 2D generation. And in this process, designers were able to explore a wide range of possibilities, producing 3 different versions of 3D sketches, 13 2D drawings from 6 different viewpoints, and 46 renderings on average. The designers' usage logs and interviews show that they developed their design in diverse modes of creativity. We identified 3 distinct patterns: single rounder, multi-rounder, and continuous switcher. For example, when P4 designed the business and family van, he first developed the overall shape of the car in the initial 3D sketching phase, then in the later 2D phase, before adding details and finalized the rendering set through iterative 2D drawing and 2D generation. Second, when P1 designed the pickup truck, he quickly built the overall shape through 3D sketching, then created renderings for all 3 views to review the design. And as new ideas emerged, he refined the 3D sketch and produced the final rendering set again based on the updated 3D sketch. Lastly, when P3 designed a large family car, he developed the design in a rather exploratory way by obtaining new ideas from 2D generation, feeding it back to 3D sketch, and repeating it multiple times until he collected desirable images. And all throughout this process, the designers switched between 3D and 2D every 6 minutes on average, and noted that the seamless transition between 3D sketching, 2D drawing, and 2D generation helped them really stay fully immersed in the design process. Finally, designers strongly agreed that the system is easy to learn, easy to use, helpful for maintaining view consistency, and steering AI-based design development, which make it highly applicable to real-world car exterior design practice. In summary, we proposed a 3D sketching plus 2D Gen AI for car design, developed a system that facilitates seamless transitions, and showed that our workflow can effectively support car design practice. As I conclude, let me highlight 2 things. First, sketching is about asking questions and shaping our thoughts, so its value is not only in the final result, but in the process itself. So even in the era of generative AI, I believe it's important to keep supporting designers in sketching better, which is a purely creative work, and let the AI assist designers properly. Second, if you want to help designers sketch, please consider 3D sketching. It is fast, faithful to designer's intent, iterative, and rich in 3D information. It can work in strong synergy with generative AI, each enhancing the other. So thank you for listening, and a lot of thanks to my collaborator, Jung Chae, in the photo, and please ask questions.
Thanks, Sunjun. Question, Karthik, I think.
Yeah, thank you. I really enjoyed your presentation, Karthik Ramani from Purdue. So typically in concept design centers for cars, right, both the surface design team is coupled with structural design team, because oftentimes you can have very nice looking overall designs, maybe even consumers may like it, but the structural design constraints are not satisfied. Do you have any thoughts about how you might combine these approaches with the structure part?
So even the concept designers have a lot of expertise in structure, because they know that if they first have to sketch a very feasible sketch at the first time to make it really come to the real world. So when our designers tested our system, they said that 3D sketching really helps them consider the structure of the car, because it's in 3D at the first time, so they can make a more feasible car at the same place more earlier in the design practice. And all these 3D curves are the 3D data, so they can be used to validate and improve on the structure-wise in the later design process.
Awesome. Let's thank Sunjun again. I think we probably don't have time for another question. Yeah, but our authors will be